So I hope some of you are making use of these recordings so that if you miss a class, you can always make up your class, or if you want to review a class, it's all there for you. Number 1 says simplify the rational expression x squared minus 8x plus 15 over x squared minus 3x minus 10. And when we say simplify a rational expression is simply an algebraic fraction. Simplify it means reduce it as much as you can. And what we said is when we have polynomials, which we have in this case, we have a trinomial over a trinomial, before we do any reducing, we've got to factor so that we can cancel out like factors. Now, both of these are trinomial factoring, and trinomial factoring is going to be on the midterm, even though this chapter is not, the factoring part is. Factoring the numerator, the x squared, remember this is the easier type of trinomial factoring because the number in front of the x squared, the leading coefficient, has to be 1. So we can break up the x squared into x and x. Remember, we then look at the last term, which is positive. It means both signs are going to be the same. Looking at the middle being negative, both signs have to be negative. And now we're looking at numbers that have to multiply to 15. And since this is a plus, they have to add to 8. And if they multiply 15, add to 8, they have to be 3 and 5. So those are the numbers we put in here. That's factoring my numerator. Factoring my denominator, again, I have a leading coefficient of just plain x squared. So again, I'm going to break it up into 2 parentheses with x and x. In this case, my last term is negative. Therefore, it means that one sign in one parenthesis is going to be positive and one's going to be negative. Because when your final answer is negative, in order to get a negative, you have to multiply the positive and a negative. And now we're looking for numbers that multiply to 10, but since this is a minus, they have to subtract a 3, and that would be 5 and 2. And since the 3 is negative, the larger number, the 5 goes with a negative, and the 2 goes with a positive. Once we've completely factored, we can now cancel out, reduce the like factors, which in this case is an x minus 5 on the top and an x minus 5 on the bottom. And my final answer becomes x minus 3 over x plus 2. Remember that when we're dealing with polynomials, specifically binomials, but any polynomials this really works with, they can only be canceled out if they are identical. It can't be an x minus 5 with an x plus 5. It has to be an x minus 5 with an x minus 5. The only exception to that rule is the fact is sometimes the order is switched, not the sign, but the order. In other words, instead of, let's say, having an x plus 2, you have a 2 plus x. Those can be, they mean the same thing. X plus 2, 2 plus x are identical. They can be canceled out. When the signs are minuses and the order is switched, they're the same number, but they're opposite signs. So when you cancel them out, you can cancel them out if the order is switched. But in this case, when there's a minus, if there would be an x minus 3 and a 3 minus x, you'd have to put a negative 1 in the place of one of them. Usually we put it in the numerator. But in any case, the answer to this question is x minus 3 over x plus 2. Are there any questions about this? Okay, so now let's look at question number 2. It also says simplify. In this case, we have a squared minus 14a plus 45 over a squared minus 81. And again, these are polynomials in both the numerator and denominator, so we have to factor the a squared minus 14a minus 45. We're going to again break up into a and a. Again, my last term is positive, means both sides are the same. The minus in the middle means they're both going to be negatives. And numbers that have to multiply to 45, but when we add them give us 14. That's 9 and 5. So my numerator factors to a minus 9 and a minus 5. The denominator is a binomial that happens to be the difference of squares. A squared is a and a. 81 is 9 and 9. There's a minus, so it factors into what we call conjugate binomials. A plus 9 and a minus 9 on the bottom. And then we see an a minus 9 on the top. Don't cancel it with a plus 9. They have to both be, if this is a minus 9, it has to have an a minus 9. We cancel it out, and my final answer becomes a minus 5 over a plus 9. I hope you were able to do these two problems. Any questions about these two problems? Okay, so let's go on to question number 3. Okay, I'm going to be erasing this. It says perform the indicated operation and simplify. And it's an x minus 2 over a 5x plus 7y times, and remember the time sign can be an x, or very often we just use a dot, or sometimes we just put the two fractions right next to each other. The second fraction is 25x squared minus 49y squared over x squared minus 9x plus 14. And again, just as we did before, when we were simplifying, we factor everything completely. So there's nothing to factor over here. These are factored completely. I'm going to factor and put the factors on top. 25x squared minus 49y squared, again, is the difference of squares. So that will give me 5x plus 7y and 5x minus 7y are two conjugate binomials. Now I'm putting two lines through this. I want to see what's underneath, but I want to know that I've crossed it out so that what I'm using is the new thing that I wrote on top. The same thing over here, I'm going to factor this, the x squared into x and x. Again, my last being positive means both sides are the same. They both have to be minuses. And they have to multiply to 14 and add to 9, which is 7 and 2. Okay. And now I can try and cancel out. Remember, any numerator with any denominator. It cannot be a numerator with a numerator, a denominator with a denominator. It has to be a numerator with a denominator. Okay, so now we have an x minus 2 on here in the numerator. There is an x minus 2 in the denominator, so I can cancel that out. Whenever something totally cancels out and there's nothing less either in that numerator or denominator, I put a 1 there to remind me that it's not 0 that's there. It's not nothing. We're canceling out by division, and the answer is 1. Okay, this x minus 2 cancels out with this x minus 2. I'm still left with an x minus 7, so I don't have to put a 1 there. Then I have 5x plus 7y here. That cancels out with the 5x plus 7y over here. Now I'm going to put a 1 here because there's nothing left there. And I'm left with a 5x plus minus 7y on top, but nothing to cancel it out in the bottom. So now I can just multiply the numerators together. 1 times 5x minus 7y gives me 5x minus 7y. And in the denominator, 1 times x minus 7. So my denominator. And I cannot, don't try and like canceling out these 7s. When you're dealing with binomials, when you're dealing with polynomials, the polynomial is its one unit. It has to stick together. The only time we can take things apart is if we have monomials. Any question about this? Okay, let's see if we can do number 4. And again, asks us to perform the given operation. And we have 2x minus 3 over x squared minus 10x plus 25. And it's times x squared minus 25 over 10x minus 15. And again, I can't start canceling things out until I have factored and can cancel out the whole factor. I can't take pieces like x squareds or 25s and cancel them out. It has to be a whole unit. Now 2x minus 3, there's nothing to factor here. But this x squared minus 10x plus 25, we can break that up into here. It's x and x. Okay, we know our signs. This is plus, they're both the same. This is minus, they're both minus. What multiplies to 25 and adds to 10 is obviously 5 and 5. Okay, so that takes care of that. This is a binomial squared, a perfect square binomial, but we can leave it separate as x minus 5 and x minus 5. The x squared minus 25 is a difference of squared, so that becomes, remember, x plus 5 and x minus 5. It's one is positive, one is negative, conjugate binomials. And finally, 10x minus 15, there's a common factor of 5. And it's 5 times 2x minus 3. Okay, so step 1, that's the hard part. We've done all the factoring. Now we want to see what we can cancel out. Well, there's a 2x minus 3 on top. I can cancel it out with this 2x minus 3 on the bottom. Notice I'm putting a 1 here because everything canceled out from here. This, I'm not putting a 1 here. I could, but it would be 5 times 1 would still be 5, so I don't need that one. Okay, now we go over here, x plus 5. Is there any x plus 5 in the denominator? And there isn't. There are only x minus 5s. I cannot cancel an x plus 5 with an x minus 5. Out of the question. But this x minus 5 can cancel out with one of these, not with both of them, but with one of them. And now let's see what we're left with. In the numerator, I have a 1 and an x plus 5. 1 times x plus 5 is x plus 5. Remember, this is a multiplication. We're multiplying. Then we have the denominator, x minus 5 and 5. When there's a monomial, a single term, and a polynomial, usually the monomial is put first. So this is going to be 5 and x minus 5 in parentheses. Actually, this is the answer I would prefer to see, but you could have also written it x plus 5, and the denominator, you could write this as 5x minus 25. In other words, you could remove this parentheses by using the distributor property. I prefer this answer, but this answer is also totally correct. And if you're looking at a multiple choice question, Either answer might pop up and they wouldn't give you both. They would give you one or the other, but you should know that these are both correct versions of that answer. So that takes care of multiplication of rational expressions. The next two questions have to do with division. Number 5 looks like this. Again, it says perform the indicated operation and simplify. We have x over x squared minus 25 divide by 5x over x plus 5. And this is not a multiplication, this is a division example. And when we're dividing fractions, we have to remember that before we do anything, we have to take the reciprocal of the second fraction. We leave our first fraction alone. And the second fraction, we change the operation to multiplication by taking the reciprocal of that fraction. So I flip the second fraction. And now it's a regular multiplication example. We do like we did before. We factor, well, this x squared minus 25 becomes x plus 5 and x minus 5. And everything else is simple, so we don't have to factor it. We have an x over here, which is a monomial. Monomials can only cancel out with other monomials. This 5x happens to be a monomial also. 5x means 5 times x. So x is a factor of both the x and the 5x. So canceling out the x leaves me 1, and canceling out the 5x, when I divide x into 5x, it leaves me 5. So notice in the monomials, I can sort of take it apart because 5x means 5 is a factor and x is a factor. I can cancel out the common factor of x. The x plus 5 over here can cancel out with this x plus 5. And if you notice, both of my numerators turned out to be 1 because everything canceled out from my numerators. So my numerators become 1 times 1, which is 1. And my denominator becomes x minus 5 and 5. And remember, I like to put the monomial first, so it's 5 parentheses x minus 5. So that the only difference between a multiplication and a division example is the fact that you first flip your second fraction and then you just do multiplication. Any questions about these? Okay, so let's look at the last question that I had asked you to look at. It looks like this. X squared minus 9 over x squared minus 10x plus 24 divide by x plus 3 over 2x minus 12. And again, this is a division example. I'm going to have to take the reciprocal of the second fraction because it's a division. And I'm going to have to factor everything so I can see what I can cancel out. So as I rewrite it, I'm going to factor it. The x squared minus 9, I'm going to factor to x plus 3 and x minus 3. Everybody sees that that's the difference of squares. The x squared minus 10x plus 24, well, let's see what we're going to get when we factor that. It's going to give us x and x. Again, the last sign being positive means both signs are the same. The minus in the middle means they're both minus. And we need two numbers that multiply to 24, but when we add them, give us 10, and that's 6 and 4. This now becomes a multiplication, and the 2x minus 12, which was in the denominator, now comes up to the numerator. We're taking the reciprocal. And we can factor out a 2 from there. So this becomes 2 times x minus 6. That's now in my numerator. My denominator is x plus 3. There's nothing to factor there. So now I factored everything and I have taken the reciprocal. So I'm ready to proceed by canceling out any like factor from the numerator and the denominator. So there's an x plus 3 here. It cancels out with this x plus 3. Remember, not the x minus 3, but the x plus 3. The x minus 3, nothing to cancel with. The 2, nothing to cancel with. The x minus 6, though, can cancel out with this x minus 6. And now I've canceled everything out. Let's see what I'm left with. In the numerator, I have an x minus 3 times a 2. Remember, I like to put the monomial first. I don't have to multiply that. I can leave it in factor form. And in the denominator, I have an x minus 4 and a 1, which is just x minus 4. And that would be your answer in simplest form to this example. So this takes care of what we had learned as a review of what we had done on Thursday. Does anybody have any questions before I go on? Okay, so then let's start. I'm not going to complete it today. Today I'm going to start by talking about combining fractions by adding and subtracting. Usually when we're dealing with things, we usually do about adding and subtracting before we do multiplying and dividing. The only reason we don't when it comes to fractions is because actually it's easier to multiply and divide with fractions than it is to add. So I want to go through the steps of addition of fractions with just regular number fractions so that we can remember how to proceed when it becomes a more difficult example with rational expressions. Okay, so let's look at something like this. Suppose I want to add 2 sevenths plus 8 sevenths. Now, let me just make a comment about this second fraction. Most people don't like fractions where the numerator is larger than the denominator. We call it an improper fraction. That you did when you were in elementary school, maybe in high school. But when it comes to algebraic fractions and algebra, we don't really care if the numerator is larger than the denominator. The fraction is a perfectly legal fraction, and we will often use fractions where the numerator is larger than the denominator, and we'll leave our answers that way as well. In other words, you do not have to change 8/7 to a mixed number. You can leave it 8/7. Now, when it comes to adding fractions, what you must have is something called a common denominator, or something that we sometimes call an LCD, least common denominator. The two denominators of the numbers that you're adding, the fractions that you're adding or subtracting, have to be the same. And if they are the same, then the way you add the fractions is by just adding the numerators. 2 plus 8 is 10. Your answer in this case would be 10/7. You then look to see if you could reduce this fraction. Is there a common factor in the numerator and denominator? If there is, then you reduce your fraction. But the important thing is to have a least common denominator or a common denominator, the same denominator for both fractions, and then you just add your numerators. Or if the operation is subtraction, you subtract your numerators and leave the common denominator. You do not add or subtract your denominators. So that's very different. I'm sure you remember doing this when you were in elementary school. I'm not going through the whole process as to why it works. That is the way adding and subtracting of fractions works. Our question is, what happens when we don't have a common denominator? Let's see what happens if we have two fractions and the denominators are not the same. So let's say I had 5/6 minus 7/8. Suppose I want to, this is a fraction problem, but the same thing. I want to subtract the two fractions, but the two fractions don't have the same denominator. We do not have a common denominator. What we do is we want to rewrite these fractions so that they have the same common denominator. How do we find the common denominator? Here's what we do. We look at the factors of each of the denominators. In this case, what does 6 multiply? 2 times 3 gives us 6. And the 8 is 2 times 4. I know we could go further with this, but this will work perfectly. When you want to find the least common denominator, what you do is you start with your first denominator, which in this case is a 6, and circle all the factors of that denominator. I'm specifically doing this in a manner that will apply to algebraic fractions as well. You then go to your second denominator and circle anything that hasn't been circled before. Well, 2 has already been circled, so I don't need it to be circled again, but 4 has not. So therefore, I now have 3 numbers circled, 2, 3, and 4. Multiply those numbers together. 2 times 3 is 6. 6 times 4 is 24. 24 will be your LCD, your least common denominator. Now, there is another way you could do it when you just have numbers. You could just take the larger number, the 8, and say, oh, does 6 divide into 8? No. So let's do 8 times 2, that's 16. Does 6 divide into 16? No. Then do 8 times 3 is 24. Does 6 divide evenly into 24? Yes. Therefore, 24 is your least common denominator. If you've doing it with numbers, sometimes you could just sort of pick it up. But if not, you can use this factoring method where you just break down your numbers into their simpler parts and multiply the ones that are different. The 2, the 3, I don't have to do this 2 because I already have it included over here, and the 4. Now, once you've decided what your LCD is, that's your first step. Your second step is to do something called rename the fraction. I had started out with a fraction, let's say this 5/6. Originally, its denominator was 6. We now want its denominator to be 24. That means, well, if I divide 6 into 24, it means that I multiplied the denominator by 4. In order to make sure that we don't change the value of the fraction, what we do is we multiply the numerator by that same number. 4 times 5 is 20. In other words, we're doing just the opposite of reducing the fraction. In reducing the fraction, we're dividing both the numerator and the denominator by the same number. When we're trying to find a common denominator, we're multiplying the numerator and denominator by the same number. As long as we multiply or divide the numerator and denominator of a fraction by the same number, we do not change its value. Then we go to the second fraction. In this case, I'm going to see 8 into 24 gave me 3. In order to get from 8 to 24, I had to multiply by 3. How did I figure that out? By dividing the 8 into the 24. Again, whatever I've done to the numerator and denominator, I've got to do the same thing to the numerator. So therefore, 7 times 3 gives me 21. 21 over 24 is the same as 7 over 8. And now I'm back to square one, where I have two fractions that I want to combine. They have a common denominator. So remember, I just, in this case, instead of adding the numerators, we did subtract. 20 minus 21 is -1. And we put our answer over the common denominator. And you could either put the negative in the numerator, or you could put it in front of the whole fraction. That means the same thing. -1 over 24 would be the answer to this example. So when we have fractions that we want to add or subtract, we want to find a common denominator. Once we have it with a common denominator, we just work with the numerators. Now, I'm going to see how this applies to examples that have variables as well. What happens if we have letters as well as numbers in our fractions? And we're going to do this in 2 steps. Step 1, which is what we're going to be finishing today, is we're going to talk about when our fractions have denominators that are monomials, single terms. And on Thursday, we'll continue it by finding out what we do if our denominators are polynomials. How do we work with that? So let's look at an example where we have some variables in our example. Suppose I gave you a problem that looks like this. Suppose I have 3 over 2x squared minus 5 over 6x. And I want to combine these 2 fractions. I'm going to show you a longer way, and then I'll really show you a shorter way that works when your denominators are monomials. It doesn't matter whether your numerators are monomials or not. Your denominators are monomials. So the first thing you've got to do is find a common denominator. One way is the way we did before, is by factoring, writing out the different factors of our denominator. In other words, 2x squared is 2 times x times x. And our other denominator, 6x, is 2 times 3 times x. And if we circle our different factors, remember we start with our first fraction and circle everything from the first fraction. Then we go to our second fraction, and I see a 2 has already been circled, so I don't have to circle that 2. A 3 has not been circled, so I'm going to circle that 3. And an x has already been circled. I don't have to circle that. If there were each x over here corresponds to one x over there. So if I had, let's say, 4 x's over here, it would only 2 of them would be considered having been circled. But in this case, there are 2 x's that were circled. Obviously, x takes care of x. So if I look at all the things that I have circled, I have a 2, an x, and a 3. If I multiply those all together, 2 times 3 gives me 6. X times x gives me x squared. My LCD is 6x squared. Now, there is a shorter way we could have done this. When we're dealing with monomials, we can separately deal with the numbers and with the letters. In other words, the 2 and the 6, I say, oh, what's the common denominator of 2 and 6? What number can be divided by both 2 and 6? Now, we're not looking for a factor. We're looking for a common denominator, a common multiple is what it's called. So the number that both 2 and 6 can be divided by can be divided into. 2 and 6 both divide into 6. So our common denominator for 2 and 6 would be the 6. That most people could figure out without having too much difficulty. What about the variable parts? Well, I look at whatever letter I have. In this case, I have an x squared. If I have a letter, a variable in my denominator, then I just take the highest exponent of that variable. There's an x squared and an x. The highest exponent is 2, so x squared is the variable part of the common denominator. So I could have done this not by the factoring method, but by what I call the inspection method, looking at the 2 and the 6 and picking the 6 and the x squared and the x and picking the one with the highest exponent. Again, it's not a factor, it's a common denominator, so it doesn't look for the lowest exponent, we look for the highest one. Okay, once we've decided what our common denominator should be, we now have to rename our fractions by dividing the original denominator into the common denominator. So 2 into 6 gives me 3, and x squared and x squared cancels out. The only thing I've done to this 2x squared to get to 6x squared is I've multiplied by 3. Since I'm multiplying the denominator by 3, I have to multiply the numerator by 3 as well. 3 times 3 gives me 9. So my original fraction of 3 over 2x squared becomes 9 over 6x squared. And we don't reduce here. We want the denominators to stay the same. I go to my second denominator. 6 into 6 cancels out. X into x squared gives me x. I have multiplied this 6x by an x to get 6x squared. So now I have to multiply the numerator, the 5, by x as well, and that gives me 5x. And now we, in this case, subtracted the numerators. 9 minus 5x, they're not like terms, so I can't combine them, and put them over my common denominator of 6x squared. And I could only reduce this further if there would be a way to factor the numerator, because the numerator is a polynomial and we can only cancel out when we have factors. It's not factorable, so there's no like factor from numerator and denominator. So this would be my answer. Okay, let me see if I can give you one to try while I take attendance. I'm going to give you an example for you to work out. Okay, I'm giving you the example where I want you to combine 3 over 4x minus 1 over 8x squared plus 2 over 3. And I want you to find the common denominator and then rename your fractions while I am taking attendance. Then we're going to, what I'll do after this, the homework on Delta Math that you're, the current homework will be including these type of problems. Again, it's due for next week sometime. Do it when you have a chance. Anybody who needs extra time in doing any of the homework, just email me. If you email it to me, I can always override whatever is happening either on the Delta Math or on the Blackboard, but you have to let me know that you're having a problem. The only thing I will not be able to do is be able to reset the midterm unless your internet goes down and you're cut off in the middle of the test. I really have to, if you make a mistake and you shut your or submit your test before you're finished ready to submit it, it's just gonna, that's the mark you're gonna get. Now, you also have to know that the time allotted is the time allotted. You are not going to be able to get extra time. Again, on the practice, yes. If you want extra time, if you want to retake the test, if you want to redo it another time, just to see, just as practice, I will definitely allow you to do that. Just email me and I will reset it. I can't reset part of it. If I reset it, it just starts off from the beginning again. So you must know that anything that's done before is lost. But if you want to redo the test, that is fine. But you will not be, I can't give you that option when it comes to the midterm. All right, is everybody okay with this? Okay, no questions, so I guess we're okay. We want to first find the common denominator. Now I'm going to do it the easier way because these are not hard numbers. There's a 4, an 8, and a 3. The number that goes into, that all of these numbers go into, has to be 24. So And then I just, by trying my largest number, again, the easiest way to do it is try your largest number, which in this case is the 8. 3 doesn't go into 8. 4 does, but 3 doesn't. If I do 2 times 8 and I get 16, 3 still doesn't go into it. But if I do 8 times 3, I get 24, and 4 divides evenly into 24, gives me 6. 8 into 24 gives me 3, and 3 into 24 gives me 8. All of the numbers go into 24. So in terms of the coefficient, the number itself, the common denominator is going to be 24. In terms of the variable, that's the easier part. I have an x, an x squared, no x. The largest I see is an x squared. I have to take the largest exponent of the variable that I see. So 24x squared is going to be my LCD. So that's step number 1. Step number 2 is to rename the fraction. We divide the new denominator, the original denominator, into the new denominator. 4 into 24 gives me 6. X into x squared gives me x. I have multiplied the 4x by 6x to get 24x squared. I find that by dividing the original denominator into the new denominator. Whatever I multiplied the denominator by, I've got to do the same thing to the numerator. So I'm going to have to multiply this 3 by the 6x. That'll give me 18x. Okay, now I have 8x squared. 8 into 24 gives me 3. The x squared is canceled out. I have to, I'm going to just put it over here. I have multiplied the 8x squared by 3 to get 24x squared. So I have to multiply the 1 by the 3 as well. And this gives me 3 as that numerator. Then I divide the 3 into the 24, gives me 8. And just bring the x squared because there's nothing to divide into the x squared. I have to multiply this 2 by the 8x squared. That gives me 16x squared. Okay, now I'm just going to cross these things off because these were just helpers that I needed in order to figure out what to do. And now I just combine all the like terms, and there are no like terms. I'm going to rewrite my numerator in descending order. The first thing is going to be a negative 16x squared. Then there's going to be a plus 18x and a minus 3. And that's all over 24x squared. In order to reduce this any further, I'd have to be able to factor the numerator, and it doesn't look like there's any common factor or anything that I could use. So this becomes my answer to my question. I have everything with a denominator of 24x squared. I don't know if anybody was able to do that, but it really, this would be the answer to that question. Okay, so I am now going to, we're going to leave the remaining part of adding and subtracting of fractions when our denominators are more than just a single term, that we're going to learn on Thursday. Okay, so
I have a question.
Sure. Who's asking me a question?
Alexandra,
Yeah,
did the change? Because I see that it's plus, it's negative and plus, and then they change to negative and negative. No, above.
Oh, no, that's my fault. You're right. This should have been a plus.
Okay, thank you.
I just rewrote it wrong. Thank you so much. Okay, no, it shouldn't have changed, and it should have been a positive 16x squared, a positive 18x, and a minus 3. Thank you, Alexandra. Okay. So I'd like to go back and just do that last bit of review. You'd like me to do another one. You know what? Let's leave it because I really want to have some time for review, Dominic. I will review, I'll do some more of them on Thursday. Is that okay? Rather than spending more time now and not having any review time. Okay, great. You can always come on, and if you want to come on early on Thursday, also I can do some with you just privately. Is that okay? I will make it a point to be here on Thursday by 22. In other words, by 11:40. So if anybody has any questions on this, you can always ask me. Great. Okay. So I want to go back and review the one major topic that I haven't reviewed for the midterm, and that has to do with how do you write the equation of a line. And there are a couple of types of situations where they may ask you to write the equation of a line. Number one, it could be a simple thing like this. If I tell you the slope of my line is -2, and it passes through the point 5, -7. And I ask you, write the equation of the line. That's one type. In other words, I actually tell you what the slope of the line is, and I tell you a point on the line. So whenever we go to write the equation of a line, we want something in the form of y equals mx plus b. This is what's called the slope-intercept form of the line. The m is the slope of the line. The b is what we call the y-intercept. Now, I already told you what the slope of the line is. I told you the slope of this line is going to be -2. So my equation of my line is going to be y equals -2x plus b. We always start by putting in the number that is the slope of the line. And then go and try and find out the y-intercept. Now, this is not the y-intercept. We can't say that the y-intercept is -7 because the only time a point is a y-intercept is if the x value is 0. But since this is a point on the line, I can replace the x with 5 and the y with the -7, and that'll give me a correct value for the b. Because any point that's on a line has to fit into the equation of the line. So replacing the y by -7 and the x by 5, I get -7 equals -2 times 5 plus b. And I just solved that. -7 equals -10 plus b. And when I bring the 10 to the other side, I get -7 plus 10, which is 3. So now I know that my equation of my line should be y equals -2x plus 3. The b worked out to be 3. And as a matter of fact, if I asked you what is the y-intercept of this line, you would tell me the y-intercept is 3. That means 0, 3. Because the y-intercept always has the x value being 0. Okay, so that's one type of question that could be asked in terms of writing the equation of a line. Okay, what's another type of question? Well, let me see if I can. Suppose I gave you this question. I want the equation of a line that contains the points 4, -3, and -8, -7. And I want it written in the slope-intercept form and the y equals mx plus b form. So this is another type of question that can be asked. How to write the equation of a line knowing 2 points on the line. And again, remember that my equation of a line is y equals mx plus b. And again, the first thing we're concerned with is the slope. We want to figure out what is the slope of this line. And since we have 2 points, we can use the special slope formula that goes like this. Y equals y2 minus y1 over x2 minus x1. I just arbitrarily pick one point to be my first point, so that's the x1, y1. And the second point then becomes the x2, y2. Remember that these subscripts just are indicating the x of point 1, the y of point 1. This is the x of point 2, and this is the y of point 2. And substitute these numbers into my formula. So y2 is -7 minus -3. That's the y2 minus y1. And the x2 is -8 minus 4. And if I work this out, a negative and a negative becomes a positive. So this becomes -7 plus 3, which is -4. And -8 minus 4 is -12. First of all, a negative over a negative becomes a positive. And this could be reduced, 12 over 4 can be reduced to 1 over 3. The slope of this line is 1/3. So now I substitute it into my equation. Y equals 1/3 x plus b. So again, first thing we've concentrated on is to find the slope of the line. The other question, they actually gave me the slope. Here they gave me 2 points, but that enabled me to find the slope. I still have to figure out what the b is. And again, I do it by picking either one of these numbers. I can either pick the 4 -3 point or the -8 -7. It doesn't make a difference. This looks like an easier combination. You're going to get the same answer no matter which point you pick. Let's say I pick the 4 -3. That means the y is going to be -3 when the x is 4. So this gives me -3 equals 1/3 times 4 plus b. Now, the hard part about this is going to be the fractions. And if you recall what I said, when you have fractions and whole numbers, it probably makes most sense to just put ones under the whole numbers so everything looks like it's fractions. And this gives me -3 over 1 equals, well, nothing cancels out, so this becomes 1 times 4, which is 4 over 3 plus b over 1. And if you recall what I said is you find the common denominator, and between 1, 3, and 1, well, we've just figured out what common denominators, that's going to be 3. Multiply everything by the common denominator, 3 over 1. Now, when I distribute this, this becomes 3 over 1 times -3 over 1 equals 3 over 1 times 4 over 3 plus 3 over 1 times b over 1. And here, nothing cancels out. 3 times -3 is -9 over 1. Here, the 3's do cancel out. And I have 1 times 4, so it's 4 over 1. And here, nothing cancels out, so that becomes 3b over 1. Now, once everything is over 1, I'm going to go over here. I really don't need those 1s. This really means -9 equals 4 plus 3b. And bringing the 4 to the other side, I get -13 equals 3b. And my b turns out to be -13 over 3. So my equation then becomes, here's my final answer. Y equals m, which we know is 1/3, 1/3 x, my plus b, so that's -13 over 3. And this would be your answer for your equation. Again, you find your slope, in this case using the slope formula, and then you find the y-intercept by sticking either one of your points into the equation once you've filled in the slope, and then work it out. Again, if you know how to use your calculator, you could have used your calculator to work this out also. You could have just worked the whole thing out using your calculator. Okay, so that's another type of question. And let's do one more of these types. Okay, I'm erasing this. Okay, so let's say I gave you this question. I want you to write the equation of the line that's perpendicular to the line -3x minus 5y equals -6, and have a y-intercept of 3. Let's see if we can write the equation of that line. Okay, now let's call this line A. Line A is the line they're giving me. We want to write the equation for line B, which has the property of being perpendicular to line A and having a y-intercept of 3. Now, we know that telling us about parallel and perpendicular tell us about the slope of the line. 2 lines that are parallel have the same slope. 2 lines that are perpendicular have opposite reciprocal slopes. So what I need to do is first figure out what the slope of this line A is. And then, since it's perpendicular, my new line, my line B, the line I'm writing the equation of, will have to have a slope that is the original slope flipped and changed signs. Now, in order to find the slope of line A, we have to put line A, the negative 3x minus 5y equal negative 6 in y equals mx plus b form. So I'm going to add 3x to both sides, which will give me negative 5y equaling 3x minus 6. And then I have to divide everything by negative 5. I have to solve for y. This gives me y equals, well, 3, this is negative 3/5 x. And negative is positive plus 6 over 5. And the only thing I'm interested in is the number in front of the x, because that is the slope. The slope of line A is negative 3 over 5. I got that by putting the original line A in y equals mx plus b form, and then looking at the coefficient, the number in front of the x. So the slope of line B, which is going to be perpendicular to line A, is going to be positive 5 over 3. I flip it over and change its sign. If it was going to be parallel, I would have just used this negative 3/5, but it's perpendicular, so I have to take its opposite reciprocal. So here's my equation for line B. It's y equals m, which is 5/3, x plus b. But look at what they told us what b is. They told me the y-intercept is 3, so it's plus 3. I didn't have to work anything out because they already told me what the y-intercept is. Okay, that are the only other thing that we might be asked has to do with two special kinds of lines. The lines that are either horizontal or vertical lines. Let's just review that, and then I'll give you time to ask any questions. Okay, let's say I give you something like this. I give you the point negative 2, 3, which is right here, negative 2, positive 3. If I want to write the equation of the line that's the horizontal line, the line that's parallel to the x-axis, through this point, when it comes to a horizontal line, the equation is always y equals a number. A horizontal line has no x's in it in its equation. It just has a y, and the y is whatever the point is. So it would be y equals 3. And that line happens to have a slope that's equal to 0. A horizontal line, remember, slope is rise over run. It doesn't rise at all, so its slope is 0. When it comes to a vertical line, say we have a line like this. Here's a vertical line. A vertical line is a line that goes up, right up and down. The vertical line has an equation x equals a number. It has no y in it, it's just x. And the x is whatever the x of the point is. In this case, it's x equals -2. In terms of the slope does not exist. A vertical line has an undefined slope, a non-existent slope. We can't talk about the slope of a vertical line because if we tried to figure it out, we'd get a number with a 0 in the denominator, and that is undefined or does not exist. So those are the two special lines, and those are the most important features that you have to know about writing equations of lines. Now, does anybody have any questions they want to ask me?